Hey, this is Steven from LegitTechTutorials, and welcome back to Intro to Computers. Today we're going to talk about graphics cards. Now, graphics cards are required. You need some type of graphics card or some type of graphics chip. So as you saw in the previous processor section, you could have an integrated graphics. So like the Intel HD graphics, or like the AMD Radeon graphics for AMD. So those are integrated graphics. Now you could use those for basic stuff. You can't use those for gaming, and they're probably not the best for accelerated workflows like video rendering, etc., etc. But you could use those to watch Blu-ray movies and stream the web, etc., etc. But if you want to play games, then you're going to want, or do any sort of that accelerated work, you're going to want a dedicated graphics card. Now, there's two different manufacturers for graphics card, and like I said, graphics cards are for displaying output, for processing video and displaying it on a monitor or a TV or whatever. So that's what a video card is, and that's what it does. And you either have two types: you have the integrated on your processor, or you have the dedicated, which is one of these guys, which I'll explain where this goes, and you'll have to call on your memory from the motherboard tutorial. Alright, so there's two different technology, the people that come up with the technology for the graphics cards. There's NVIDIA, and there's AMD. It used to be ATI, but AMD bought out ATI. So AMD makes processors and graphics cards. So this one right here is the AMD. And you notice there's different manufacturers for that same technology. This is the R9 270. So there's different manufacturers, and the reason why there's different manufacturers is that they have their own proprietary cooling solutions. As you see here, each different company has their own cooling solution. Same exact thing for why do I have TI there? Anyways, same thing here for, let me do 760 without the TI. Okay, so this is NVIDIA, and they have like 760, so they're into the 700 series. 760, 770, 780, and eventually 790 are the newest series. And this is the, which one are they on now? You see here NVIDIA. I forgot what the code name is, but the next one I think is the 800 series, and that one's Maxwell, I believe. I don't know. I don't think they really talk about on here what the actual yeah, so I don't know what the actual code is for it. Just like Intel has Haswell for the processors, the 800 series is Maxwell. I don't know what this one is. Okay, so let's go over NVIDIA first. So let's go ahead and just pick this EVGA manufactured one and go over what's going on here. Okay, so just looking from the title, it supports G-Sync, and I'll go over that in a second. So here's the model, 760. And it says GeForce GTX 760. So GTX is the performance model. You have the GT, and then you have the GTX. The GTX is the performance model built for gaming. And GeForce is standard consumer grade graphics card. Then you have 2 gigabit. 2 gigabit stands for the RAM, how much dedicated video RAM it has. And 256 is the channel bandwidth. And then you have GDDR5, which is basically a type of RAM that they use for graphics cards. And it fits in what you probably remember, a PCI Express 3.0 slot. So that's down there where the video cards go, that I talked a lot about in the motherboard, where it has the little white tabs on it. This goes into one of those PCI Express 3.0s. Now it could go in a 2.0, but you'll lose bandwidth. And then here it's explaining what type of cooler it is, their proprietary cooler, which is the EVGA ACX cooler. And then I'll go over SLI in a second. Okay, so let's go down here. Here you see the series is a GTX 700 series, and this is super clocked. and I'll go over what that means in a second. So here's the interface. It goes into a PCI Express 3.0 slot. The graphics card is from NVIDIA, or the chipset. They make the chipset. These guys manufacture the card. It's a GeForce GTX 760, and then here's the clock. So it's just like a processor. You have a core clock, and you have like a memory clock. So here's the memory clock, and here's the core clock. Now you can do the same thing as your processor and overclock the core clock, and that's what these cards are. As you see, they have a very, very high core clock. So if you see, so basically the higher the clock, the faster it is. So when you're comparing cards that have like the same amount of RAM, 2 gigs of RAM, the core clock and the memory clock are what's going to make it faster. Also, the other big thing is the CUDA cores. Now, basically, this is a what they call a parallel processing unit. That means that they have very, very tiny cores, but a lot of them. So it's just like a processor, except for it has 1152 CUDA cores, which means very small cores to do all the graphics processing stuff all at the same time, because that type of processing is very real-time related. So it has to be done really, really quickly to get those games playing as you want it to. And almost like you see in games, 60 frames per second, 120 frames per second. So it needs to get those frames out there, so it needs a lot of processing power. So that's why you use a dedicated graphics card instead of an integrated graphics card for playing games or doing stuff like that. And this has the same thing as a boost clock, so when you start to get into a game or you start to do some sort of other tedious tasks that requires it to clock up to the boost clock, then it will do that. Otherwise, it'll sit down here at the core clock or even lower to save power. And here is your effective memory clock. And here's the memory interface, 256-bit. So the higher the bit, I think the other one's like 318 is the next one up, 318-bit. But 256 is pretty big. So they have 128, 256, and 318, I think. And then up, they keep going from there. So the higher the bit, the better it is as far as the bandwidth. And then here's the memory size. So the higher the memory, the better it is. But usually you get cards with higher memory if you have more than one screen and you need to hold more textures in there. So if you're doing a multi-screen display, then you need to store more textures inside of your memory. Most games with one screen only use like 1 gig. So if you're going to do more than one screen, you probably want to go with at least 2 or 3. 2 mandatory, 3 is probably recommended. Alright, so this is talking about the API, the application, I forgot what it was called. I just saw that yesterday. I'm a programmer, so obviously on my channel, so I should know, but I forgot. Okay. So it uses DirectX 12, which is brand new, which is the most up to date. I think they have 12.1, but you know, no big deal. Open graphics library 4.3, which is pretty standard. So these are usually up to date. You don't really have to worry about these too much. And then here's another big deal: is the ports. So you have one HDMI, one DisplayPort, one DVI, one DVI-D. So these are 2 different plugs here, DVI and DVI-D. And then here's the RAM, what the RAM clock is, the max resolution, if you could do 3D, and then SLI. SLI is basically, what you could do is get multiple NVIDIA cards that are the same, I think you only need it to be in the same series and have the same amount of RAM, and you could technically do SLI across manufacturers. But SLI is basically where you could attach 2 cards or more together and have them work on the same project and have them balance each other out. So basically you scale it, but you don't get full like two times. You get like maybe 1.5 times. So if you add 2 cards, you're going to get 1.5 times the speed out of the 1 card. And it depends on the game whether it scales or even supports SLI. As some other accelerated stuff like video encoding usually doesn't use it. So it's a big gaming thing. So like you have dual SLI, you have tri SLI, and you have quad 4-way SLI. So they say 1-way SLI, 2-way, 3-way, and 4-way. And here is very important, dual slot. So this is going to make sense when we go over cases, but it takes up 2 slots in your case on the back side. And also, this is also very important as well, is you need 500 watt or greater power supply, and 30 ramps on the 12 volt rail. Otherwise, it won't even run. And it explains the card dimensions and then all this other stuff: GPU boost, physics, FXAA technology, TXAA, adaptive vertical sync, surround. So this is doing multiple monitors, 3D vision ready, SLI. CUDA technology, so you could do CUDA accelerated projects, OpenGL, and also you could stream to your Shield, and explains what's in the box. Okay, so let's take a closer look at these guys here. Okay, so let's look here at the side. So this is what it means when you're taking up 2 slots. See how it has 2 of these little fingers? So these are what go inside of your case, and that's why it says it's a 2 slot. As you can see, there's 1 slot here, 2 slots here. Some heat sinks, like I know for sure Asus has got some direct cooling proprietary heat sinks that take up 3 slots. So you really need to pay attention on that. And there's like 2 different types of video cards. There's a reference, which is basically what NVIDIA released as their design, and then you have proprietary coolers like this. That's all different. The reference, they're all the same. They just might have different decals stuck on it. This is definitely a aftermarket. So you have 2 different types of shrouds. Usually you have this, which is the more open shroud, or you'll have the more reference card stock style cooler where it only has 1 fan, and this is all closed off, which is a lot different. Okay, so let's go ahead and move on to the R9. So they have the R9 and R10 series. I'm not super in the know about oh man, I'm not super in the know about AMD too much, as you'll see later on. I'll talk about it in the in how to build a computer series. But let's go ahead and jump into the R9s here. Okay, and the R9s are a lot different as far as the specifications compared to NVIDIA, as NVIDIA has a lot of proprietary technology, and AMD is just starting to come up with some proprietary technology that's allowing them, that they're trying to compete. As you see here, the first thing you notice is that it's all set up the same, but it's got a different series number, the R9 280, and the core clock is pretty low, so they probably have an over. If you do the R270, which one was this? R9. This is 280, and then you look at the 280X, you'll notice that the clock is a lot higher. So you notice how the clock is a lot higher? So that is basically what the difference is that these guys, that the X, so you have the R9 280, and you have the R9 280X, and the X has more core clock for an extra $20 or whatever. Okay, so it's a PCI Express 3.0. All this stuff is very similar to what you saw, except for now they have stream processors instead of CUDA cores, but it's basically the same thing. And you can't really compare the two, say, oh, because the other one had 1100, this one has 1800, this one's faster. It's an apples and oranges comparison. You have to go and look for benchmarks. That's the biggest thing, is to look for benchmarks on this card and or processors to see which one you want to get. But like I said, anything about buying, I'm just introducing you to the parts here and what they do and what all this numbers are. But learning how to buy stuff is going to be in the next series. Okay, so effective memory clock is here, memory size is here, and you notice that it has a larger memory interface, but like I said, it's actually 384, so the other one's not 318, it's 384. So you have to use the benchmarks to tell which one's faster. As you notice, this one also doesn't support DirectX 12, and it doesn't support OpenGL 4.4. So it definitely is definitely limited on the technology. And here it also doesn't tell you what type of what's called power supply you need to use. Okay, so this is surround, and crossfire is exactly the same thing as SLI, where you could pair multiple AMD cards together and have them scale. And then dual slot and HDCP, don't worry about that. And here's all the ports. As you see, it's got the exact same ports as the other one, but it's also got a lower memory clock. The other one had 6,000 something or other. Okay, so let's go ahead and take a look at the card. So here again, you see how it's going to take up two slots. And here you see a big heat pipe, very large heat pipe. Okay, so I mean, basically the higher for these two products, and those are the two technology manufacturers, but they all have different actual card manufacturers, as you see here. Basically, what happens with the two is the higher up you go in the number here, or if you add something on, if it goes, there's like a 760 Ti, that means it's got more power. And sometimes with NVIDIA, you'll find a 2 gigabyte version or a 3 gigabyte version. It's all depending on whether you're going with, single screen or double screen against more than two screens. Same thing with this guy. The higher up you go in the class, I think there's an R10. So if you go to an R10, it's faster. If you go 290, it's faster. If you go 280X, it's faster. So as you go up, the faster the card gets, etc., etc. But yeah, so it all depends on what you want to do. If you're doing, if you're playing games, then you definitely need a dedicated. Otherwise, you'd go with just your integrated off your processor. All right, so this has been Steven from the LegitTechTutorials, and I'd like to thank you for watching. I think I covered pretty much everything in this video, and we'll cover even more when we go over how to actually build a PC. Alright, so if you like this video, please subscribe for more videos like it in this series and other series as well, and I will see you guys in the next video. Thanks for watching. Take it easy. Peace. Oh, also, I'm going to be, like I said, I'm probably going to write a book for this particular guy, and I'll let you know how that's going when I start it. Alright, thanks for watching. I'll see you guys in the next video. Peace.